Welcome to another Cumulus Cycles AWS hands-on tutorial. In this video, we'll deploy a Node.js app to an auto-scaled fleet of EC2 instances behind a load balancer. To get started, I'll jump over to my Cumulus Cycles GitHub repository, click Repositories, and then create a new repository to hold the Node.js app code. I'll leave it public, add a README, and a git ignore using the node template. Then I'll create it. Now I'll copy the link to clone the repo, open the terminal, and clone it. Then change directory into the project folder. From here, I'll run npm init to initialize a node project. I'll leave the package name, the version, description, and for entry point, I'll change this to app.js. And then say yes. Finally, I'll install the Express package since I'll use Express routing in the Node.js app. Now I'll launch VS Code. So I'll create a file named app.js and paste in the following code. Here I'm creating a constant named Express and requiring the Express package. Then I have a constant named app, which is an instance of an Express object. And I have a port, which is 3000, which is the port the application will listen on. In here I have a route, which handles an HTTP GET request to the root of the application. So if I were to launch this application and went to localhost 3000, I should see this HTML h1 element with the text EC2 Autoscaling Demo v1. And finally, I'm calling listen on the app, passing the port, and then logging to the console that the server is listening on localhost and port 3000. So if I save the file and go back to the terminal and run node app.js, we see that the server is listening on localhost 3000. So if I copy this URL and go back to the browser and load the page, we see our text. So I'll stop the server, and with the app running fine locally, I could push this code to my GitHub repo. And if we go back to the repo, refresh the page, now we see the application code is uploaded. Now it's time to jump into the AWS console and head over to EC2. I'll scroll down and start by creating a security group. I'll give it a name and a description. I'll stick with the default VPC and create the inbound rules. I'll add a rule for SSH and give access from anywhere, although you may want to lock this down to your private IP. Add a rule for HTTP from anywhere, one for HTTPS from anywhere, and then a custom TCP rule on port 3000 because that's the port the app runs on. And this will be accessible from anywhere as well. Then I'll create the security group. Now I'll go up the menu and click the link for launch templates and create a launch template for creating the EC2 instances. I'll give it a name, check to provide auto-scaling guidance. For the AMI, I'll select Amazon Linux and Amazon Linux 2. And for instance type, I'll pick T2 Micro. For key pair, I'll create a new key pair. Then in network settings, I'll select an existing security group and pick the security group that I just created in a previous step. Now I'll scroll down to the bottom of advanced details and paste in the following for a user data script, and then create the launch template. So what this script does is it starts out by setting the bash interpreter. Then it will configure the files for logging. Then we'll pull down MVM from the GitHub repo and then source MVM. Then we'll use MVM to install Node and export the MVM directory, then do a sudo yum upgrade and install Git. Once Git's installed, I'll change directory into the current users folder and then clone the repo from GitHub. And of course, you'll put the link to your GitHub repo here. Then change directory into the repo's project folder, apply permissions, and then execute npm install. And this will install the Express package from the package.json file. And finally, launch the application. Now I can create the auto-scaling group. Give it a name. Select the launch template I just created. Use the latest version. I'll stick with the default VPC and select the AZs and subnets. So I'll pick US East 1A, B, and C. So I want to attach a new load balancer. It'll be an application load balancer, and it'll be internet facing. And I need to change the port to 3000. Oh, and create a new target group. For desired capacity, I'll put that at 2, minimum capacity 2, and maximum capacity I'll set to 3. I want to use a target tracking scaling policy for average CPU utilization, and for the demo I'll set it to 25. And then create the ASG. And now it's updating the capacity. So if we jump over to the EC2 dashboard and go into instances, we'll see it's spinning up the two T2 micros. Now one's running and the other one's running. But I'm going to pause the video for a few minutes and give it time to download and install the packages and the source code from the GitHub repository. Alright, so I gave it a little while to download and install the packages and the code, and we see we have our two instances running. So I'll click in, then select the first instance, grab its IP, open a new tab in the browser, go to the IP, port 3000, and we see our page being served. Then I'll jump back into instances, grab the IP for the second instance, open another tab, hit port 3000, and we see our app being served there as well. Now I want to go over to the load balancer, grab its DNS name, and hit that in the browser. And right now we get a page not found, but if we target port 3000, now our page is served. Of course, we don't really want to have to point to port 3000 on the load balancer to load the site. So I'll go back into the load balancer, click on the listeners tab, and edit the existing listener and change the port from 3000 to 80 and save. Now if I go back to the browser and delete the port 3000, we see the app being served on the default port. So let's test the auto scaling we've implemented. I'm over in the EC2 dashboard. I'm going to select the first instance and I'm going to terminate it. Then I'll jump back over to the browser tab that has the IP of the first instance and refresh. And we see the request is timed out because it can't hit the server since it's down. But if I go to the tab that has the IP of the second server, that still works, as does the load balancer. But if we jump back into the EC2 dashboard, we see we still have two instances running. The first one was the second server that we initially created, and the second instance is a new instance that was spun up because we specified we wanted a minimum and desired capacity of 2 instances. And if I click this instance, grab its IP, go back to the first tab, and replace the old IP with the new, now we see the page is served. The final thing I want to do in this demo is to add some load to our existing instances so we trigger the scaling policy and add another instance. So I'll SSH into one of the servers, then execute these two commands to add the stress tools. And now I'll add stress to our existing CPUs. And then jump back into one of the instances and click monitoring. We'll see the CPU utilization has gone up and it's over the 25% threshold that I had set in the target tracking policy. And now if we jump back to the EC2 dashboard, we see that another instance is initializing. And when this comes up, we'll have 3 instances, one in each of the availability zones we specified. And if I grab the IP for the new instance, then head over to the browser and hit port 3000, we see our app is loaded. And of course, it still works on the load balancer. So that concludes this demo of deploying a Node.js app to an auto-scaled fleet of EC2 instances behind a load balancer. I hope you found it useful.